All right, so here we have a combination. So here we want to use whatever laws we know so far to rewrite this logarithm so it does not contain a power and it does not contain a product. So this is just another way to say expand. So let's expand this logarithm into multiple terms. So again, let's figure out how many terms we're going to have in our log. So we have a product of 2. So we have a times b squared. So we know that this is going to expand first into 2 terms. So it's going to be the natural log of a plus the natural log of b squared. So we've now taken care of, not the power, but we've taken care of the product. Now that we've taken care of that, we need to reduce this further because we have an exponent here. So we need to take that exponent or that power and write it out front. So we have 2 times the ln of b for our second term, and our first term will stay the same, and that's just the natural log of a. All right, our next one, we have x times y times the cube root of z. I'm trying to make sure that that's actually a cube root. Yes, it is a cube root of z. It's kind of hard to tell, but this little 3 is the index of that radical. So we're going to have 3 terms to get started with. So we have log base 3 of x. We have log base 3 of y. And we have log base 3, and I'm going to go ahead and write this as a fractional exponent, z to the 1/3. All right, so we've taken care of our products. Now take care of any powers that we have. So we need to take this 1/3 and write it out front. So we get 1/3 log base 3 of z, and the rest of these will remain the same. And so now we've expanded it so that it has no powers and it has no products. All right, if you want, you can pause the video and you can try this one. All right, so for this one, there's actually a couple ways that you could do this. So what I suggest is, since this 3 is on the outside, it's grouping both the a and the b together, you can actually implement the power rule first. So I'm going to write the 3 on the outside, and then I'm left with the natural log of AB. Now you do have to be careful with this approach, because now we have 3 on the outside, and now we're going to expand. So because we have 2 factors in our product here, we're going to have a grouping symbol so that these 2 terms both get multiplied by 3. So I'm going to use some brackets here to show my expansion. So we have the ln of A plus the ln of B. You can leave it like this, or you may expand it as the natural log of 3 times the natural log of A plus 3 times the natural log of B. Now let's look at it a different way. Suppose, what's my alternate way? So another method for this one is, if instead of me using my power rule first, I'll go ahead and distribute the power to each of my factors in here. So we have the natural log of A cubed times times B cubed. So if we do it this way, now we can use our product rule to expand this by addition. So we have the natural log of A cubed plus the natural log of b cubed. And now we implement our power rule. So we bring our 3 out front. So we have the natural log, 3 times the natural log of a, plus 3 times the natural log of b. And you'll see that we ended up with the exact same answer. Our last rule is dealing with a quotient. A quotient is another word for fraction. So if we have the log of a fraction, how do we implement or expand this? So how this works is that when you see division inside of your log, that's going to translate to subtraction. So just like multiplication translated to addition, likewise, fraction is going to translate to subtraction. So here, how you decide how many terms you have is, again, the number of factors, or the number of values that we have. So here we have an x and we have a y. So that's going to translate into 2 terms. And because the y is on the bottom, the y is going to have to be negative. So when we expand this one, we're going to end up with log base b of y will be after the subtraction symbol. And the log base b of x, you'll notice here that we have a positive coefficient in front of this. So this would be the rule for expanding a quotient of log. So looking at the natural log, same thing. So we have the natural log of x minus the natural log of y. So whatever's in the denominator, that's going to be the one that is negative. So let's take a look at a couple examples. Actually, I'm going to skip over that first, and let's take a look at this one first. So use the law of log to rewrite the logarithm so it does not contain a power or a quotient. So let's take a look at this first example over here. We'll just split this up. So the first thing I'm going to do is take care of my division first. I'm going to take care of this quotient. So we have 1 term up top, 1 term in the bottom. So we have the natural log of x squared minus the natural log of y. Now we can use our power rule. So this 2 will come out front. So we have 2 times the natural log of x minus the natural log of y, and we are done. For our second example over here, again, we have our numerator. So we have log base 2 of a cubed. And now we're going to subtract off our denominator. So that would be log base 2 of b to the 5th power. Now we implement our power rule. So we want to take this 3 and bring it out front. So that's going to be 3 times the log base 2 of a. We're going to take this 5 and bring it out front. So it's going to be minus 5 times the log base 2 of b. All right, now I'm going to go back to the examples that I skipped over. So here we have some that are expanded already, and they want us to combine this into a single log. So this would be an example of condensing. So to condense this, we have 2 terms. So let's go ahead and write our log base 3. So remember, the positive terms are going to go on top, our numerator, and the negative terms are going to go in the denominator. So our numerator is going to contain the x. My denominator is going to contain the y. So basically I didn't have to have all that, did I? So let's fix that. So we end up with log base 3 of x over y. Our second example over here. So we have 1, 2, 3 terms. So we have log base 4. All the positive terms are going to go in the numerator. So a is going to go up top. b is negative, so it goes in the denominator. And c is negative, so it also goes in the denominator. Now we have our single log. Let's see. So putting it all together. So let's just do a couple of these examples. Let me just see what kind of examples we have here. Yeah, we don't have too many. Here's an expansion one. All right, so expanding. So rewrite this expression so that no logarithm contains a product, a quotient, or a power. So in other words, they're asking us to just expand this as much as I can. So we have a quotient, and we have products, and we have powers in here. So first of all, let's take care of our quotient. So we know we're going to have two terms right now that are going to be subtracted. So we have log base 3 of x squared minus log base 3 of y times z cubed. So now we need to get rid of this power here by writing it out front. So that's going to be 2 times log base 3 of x. So that's taken care of. But over here we have a product. So we still have to expand this into two terms. So let's do that. So we're going to subtract. Now because I'm going to have to expand this into two terms, I'm going to again have it in some parentheses or brackets. So this will be the log base 3 of y plus log base 3 of z cubed. All right, so we've got to take this power and bring it out front. So that's going to leave us with 2 log base 3 of x minus, we have log base 3 of y plus 3 log base 3 of z. And I say that we get rid of this example over here for now. So I can just continue. So we end up with 2 log base 3 of x. Let's distribute our negative, minus log base 3 of y minus 3 log base 3 of z. And that is our final answer. You'll see that we have no products on the inside, there are no powers up here, and we have no more quotients. So we are good. All right, let's do an example of condensing. And again, that example that I skipped over, you can find the answer for that and worked out in the PowerPoint. And our last one here is condensing. So here they want us to apply the law of exponents and logarithms to rewrite as a single log. So this is an example of condensing. All right, so what do we do first? So as I move from left to right, let's work on bringing any numbers that are out front of our logs, bringing them up as a power. So this is going to give us log base 2 of x to the 5th minus log base 2 of y plus log base 2 of z to the 1/3. Now remember, z to the 1/3 is the same as writing the cube root of z. So I'm going to just fix that. And let's write that as the cube root of z. All right, so now we can take these three terms. I think we're ready to write them as a single log. So we have log base 2. Because I have addition and subtraction in here, we know we have a quotient. So my numerator is going to contain all the positive ones. So this is going to go in the numerator, and this is going to go in the numerator. So we have x to the 5th and the cube root of z. Now my only subtraction is log base 2 of y, so the y is going to go in the denominator.